This tutorial will be discussing chemical bonds, formulas, and types of pure substances. A compound is a combination of two or more elements in definite ratios by mass. The character of each element is actually lost when forming the compound, so what it behaves like as an element is not how it's going to behave as a compound. When compounds are composed of chemical compounds are composed of two or more elements, and these elements could be the same element or they could be different. Compounds are formed by chemical bonds. These are the results of interactions between charged particles. There are two categories of chemical bonds. There's ionic and covalent. Ionic compounds occur between cations, which are positively charged ions, and anions, which are negatively charged ions. Cations are typically metals, while anions are typically nonmetals, although there are several exceptions, for instance, polyatomic ions, which we'll discuss later. These attractions are occurring from the electrostatic attraction, the attraction between the opposite charges. Covalent compounds, however, the electrons are being shared, and they occur between two nonmetals. So let's focus more on ionic bonds. Ionic bonds consist of cations, which are metals that give up electrons, and they become positive in that process. Remember, you're losing a negative charge when you lose an electron, so that actually comes out to be positive. And an anion, which are nonmetals that take electrons, and they become negative. For instance, we're adding more electrons, so we're adding more negative charge, which means that it's becoming more negative. Ionic bonds come from the attraction of these opposite charges, which are called electrostatic forces. An ionic compound creates a solid repeating three-dimensional arrangement of ions, which is also called a crystalline or a lattice structure. Covalent bonds, however, occur between two nonmetals. The electrons are being shared between the atoms rather than one giving and one taking. There are no actual charges, a solid plus one or solid minus one. Shared electrons interact with both nuclei. And it lowers the potential through electrostatic interactions as well, but with both atoms, not just one or the other. Let's talk about now how we're going to represent these through chemical formulas. Chemical formulas indicate the quantity of each element of the compound and the relative number of ions or atoms in each. For instance, here we have carbon and 4 hydrogen. Here it tells us the same thing, but it looks differently. In chemical formulas, there's two types. There's the empirical formula and molecular formula. Empirical formulas are the relative number of atoms in each element in a compound. They're the most reduced form. So if we compare these two here, CH2 versus C3H6, this is an empirical formula because it's the most reduced form, while this is the molecular formula. Molecular formula is the actual number of atoms of each element in the compound. So let's take a second to review this. Are the following empirical or molecular formulas? If they're molecular, indicate the empirical. So let's start with the first one, C3H6O2. Those numbers are not divisible by the same number, so therefore this is a molecular formula. Empirical formula, pardon. C2H4O2. Those are all divisible by the number 2, which becomes CH2O. That means this is a molecular formula because it's reducible, and this is an empirical formula. CaCO3. 1 calcium, 1 carbon, 3 oxygen. I can't reduce that down anymore, so this is empirical. C12H18O2. Those are all divisible by 2, which means that this is the molecular formula. And the empirical formula must be C6H9O. C14H10O4. Those are all divisible by the number 2, which means this is the molecular formula. And the empirical formula would be the more reduced version, which is C7H5O2. And finally, we have C7H6O3. Those are not divisible by the same number, which means that this is the empirical formula. Structural formulas, right here, use lines to represent the covalent bonds. They show how atoms are connected or bonded together. The ball and stick model represent atoms as balls and chemical bonds as sticks. It's in a 3-dimension. It's reflecting the molecular shape. So here we see that one of the hydrogens are coming out, one of the hydrogens are going in, and these are on the same plane. It gives you a more realistic in 3 dimensions what it would look like. The most realistic is the space-filling model. It more closely represents the best estimates of how molecules actually appear. It fills the space between the atoms. Now that we have an introduction to what bonds are, let's classify the pure substances. Before, we had a category in previous tutorials where we had any substance whatsoever can be broken into pure or mixture. We're going to focus on the pure section right now. So pure substances can be further broken down into elements and compounds. Those elements can then be further broken down to atomic elements and molecular elements. The compounds can be broken down into molecules or ions. So if we're looking at the pure substances, this can be broken down into 2 categories, elements and compounds. And they can then be broken down further. When we're looking at the elements here, it can be broken down into atomic elements, which are elements that exist in nature as basic units, in other words, atoms. Or molecular elements, which are elements that typically exist as molecules. 2 or more atoms of the element bonded together. Remember, the definition of a compound was 2 or more elements, whether they're same or different. Well, now we're focusing them being on the same. Notice there's only 1 element here, only 1 element here, so on and so forth. These are the diatomic molecules. And these are the polyatomic elemental molecules, P4 and S8. We can look at the category on the other side of compounds by looking at molecular compounds. These are compounds that are composed of 2 or more covalently bonded nonmetals, whereas the ionic compounds are composed of cations, usually 1 type of metal, or anions, 1 or more type of nonmetals, and they're bonded by ionic bonds. They are represented by formula units, which is the smallest electrically neutral collection of ions, or polyatomic ions, which is an ion composed of 2 or more atoms. All the atoms share the charge. That gives you an introduction to bonding.